Hello students, before you start watching this concept video, quickly I want to tell you that you can get access to more such concept clarity classes by our experts in Turito Live Achiever classes. This program is designed for grades 4 to 12 and is available at a very nominal fee. That too from the comfort and convenience of your homes. So enroll today and get started.
Hello everyone. Today we're going to talk about this concept called photoelectric effect. So first of all, let's see what exactly is photoelectric effect. It's the ejection of electrons from a metal surface on bombarding with an electromagnetic radiation with a significant energy. What exactly that means? Suppose that this is a metal surface and obviously we'll be having electrons present in each metal. Now when we hit this metal with the electromagnetic radiation, the light in simple words I can say, then it ejects the electrons. So as soon as we hit the metal with the electromagnetic radiation, it ejects the electrons. This concept is called photoelectric effect. Photo as in light, electric is the ejection of electrons. Since it involves both the phenomena, this is called photoelectric effect. This was first introduced, observed by Heinrich Hertz in the year 1887. Look at here. What did he do? He took a metal surface, he irradiated that with the light and he observed there is a deflection in the ammeter, which means the current has flown in the circuit, and we will see current will be flown only when there are electrons passes, right. So first he irradiated the metal surface with the light of certain frequency, suppose it's nu 1, but then he did not observe any deflection in the ammeter. Next, a light of second frequency nu 2, he increased it, even then there is no deflection in the ammeter, and next he sent a light with a frequency nu 3. There he observed the deflection in the ammeter, which says the electrons has now ejected from the metal surface, and that's how we got the deflection in the ammeter, right. So he pointed that not all the radiations will lead to the ejection of electrons, but only those radiations whose energies are sufficient enough will eject the radiation. That means every metal has certain minimum energy above which only it will eject the electrons. Now that minimum energy or minimum frequency is called threshold frequency and the energy is called work function. Look at the definition. The minimum energy required to knock out an electron from the metal surface is called work function of the metal, and it is different for different metals. Threshold frequency, so in terms of frequency we can say it's a minimum frequency required, and thereby has given a mathematical expression to find the kinetic energy of ejected electron. Suppose say I have incident the metal with some 10 kilojoules of energy, a random figure I am giving. Now out of 10, 5 has been used to eject the electron. Now why do we need energy to remove the electron? Because the electrons in the atoms are bound by attraction with the nucleus. Hence, first we have to break that attraction. To break the attraction we need some energy. So we need to give the energy to the electron. So that's what the 5 kilojoules is used for. Now remaining 5 joules is there, remaining 5 kilojoules, that is used as the kinetic energy for the electron. Okay. So hence H in nu is the incident energy, that is the 10 kilojoules in that example, and 5 kilojoules is used for the ejection of electron. Next, remaining 5 is the kinetic energy. So I can take this mathematical expression to find the kinetic energy of electron ejected. Okay. All right. After this, there is this scientist named Einstein, a very well familiar one. He has given the explanation for the photoelectric effect, and for this explanation he was awarded Nobel Prize. So he used the particle nature of light to explain this concept, and the main important points are the kinetic energy of the electrons is directly proportional to frequency of light incident, and the number of electrons ejected or photocurrent is directly proportional to the incident intensity. Okay. So, that is all about this photoelectric concept. More about this one we will learn in the regular classes. Thank you.